So in today's lecture, we're going to be covering a few different concepts. Now, what I want to tell you before we even start this is nothing in this lecture is going to be needed in order to complete any of your assignments. It's sort of just some other random topics that I think is very helpful for you to know, especially in your .NET career and future, just so you understand these other technologies exist. So first I want to start with Universal Windows Platform, or UWP applications. So these applications, Microsoft's noticed that developers don't want to have multiple code bases. So you don't want to have a code base for a phone, code base for the internet, code base for Internet of Things, code base for a tablet. It would be nice to have one code base where you just target devices, but it would run anywhere. And that's what UWP apps are trying to fulfill. So if you've ever gone to the Windows App Store, that's these UWP apps. I recommend going there and downloading some and just kind of playing with them. And so in UWP, you can pick your programming language, and it's just you can adapt the controls to how they fit to the different kind of platforms. So that's where they came up with .NET Core, because they want to create these universal controls and layout platforms, and so that you could have the same code run anywhere. You can monetize your app. There's live tiles. You can choose your language like C# or JavaScript and HTML. And so they're really opening the game for how we can program for Windows. Now, I don't know how the future is going to be for UWP apps. It's kind of, time will tell. So let's take a quick look at them. I'm going to go into Visual Studio here, and let's just say File, New Project. And then over here, instead of Web, I'm going to select UWP, and we're just going to do a blank Universal Windows program. Create these real fast. Now, the reason I want to show you this is because I know we haven't actually programmed for these, but you'll notice that I open up this and it's just a XAML page. And in the XAML page, it has a thing called a page versus a window, but it still has grids and controls over here, so I can drag buttons on here. I can drag a checkbox on here. And so XAML, you could write the XAML. It's just a little bit different paradigm. They have different click events. So, I could click on a button, and then I could double click the click event, and sure enough, there you go. You just write your C# code, and you're running with it. Now, you'll also notice what's nice is I can come up here, and I can select my target. So I can look at my UI and say, oh, this is what it looked like if I ran it for a phone. This is what it looked like for a desktop. And so hopefully you can see now why it's so important to pick controls that would dynamically size based on where you're targeting for your end device. And so when we've worked with canvas and grids, that's why I've shown you things like stack panels and grids and those flow layouts versus hard coding everything is for these specific type of things. So again, I would just look up UWP apps, I'd read about the background of them, and just become a little bit more familiar. The next technology I want to talk about is ASP.NET, or web applications. Now, ASP.NET is the technology, just kind of like WPF or Windows Forms, but it's for the web. And so those are all the APIs and things like that Microsoft created so you can write web applications. In the past, there was a technology called ASP.NET Web Forms. This was kind of a cool technology where it was a user interface that you would drag and drop controls just like your Windows Forms or WPF applications, but it would generate web pages for you. Kind of an older way of doing things, but there's so many out there that I would recommend looking at that technology also. But nowadays you would do something like an ASP.NET Core web application. There's Blazor, there's ASP.NET for Angular and React. And so based on the technology is how you would create your web page, but let's just go ahead and create one of these. And so when I create this web page, it's nice because you're still using Visual Studio, you're using a tool you're familiar with, you can even write code behind, and there's different ways. You just kind of have to understand the web internet on how these pages work and learn that paradigm. So there is a good learning curve, but again, the C# and the server application part of it is going to be all in C#, so I think it would make sense. So ASP.NET is a technology I would really recommend looking into. There's actually a course at Weber State that if you enjoyed this one, I think an ASP.NET course would really round out your skills going into the real world for .NET. So the next application I want to talk about, it's kind of a fun one. It's called JetBrains dotPeak. And what it allows you to do is reverse engineer code, compiled code, back into C#. So let's remember what happens when we compile an exe. So we take our C# code, we run it through a compiler, and it generates intermediate language code. It doesn't generate machine language. Well, this intermediate language is sort of like assembler, but when you run it, the common language runtime compiles it down into machine language on the fly, and so it's at runtime. So what that actually means then is if I were, for example, to open up the DB class example. Remember our data access class had like execute SQL and execute scalar to connect to a database? Well, this is the exe, that whole application to do that. Let me open this up and watch what happens. I can now open this up. Now remember, this was the exe. This was not source code. And I could come up here, and sure enough, here's my data access class. And look what it gives me. The exact code that I wrote. So hopefully your eyes opened a little bit wider right there with the idea that what if you gave your code, what if you distributed your exe or your DLL over the internet? Someone can reverse engineer your code and they can steal your IP or your intellectual property. So there are what are called obfuscation tools which make it harder to reverse engineer code like this, but with enough time for .NET, people could always reverse engineer it. Something to keep in mind. But there also are tools to compile down EXEs, but then you can redistribute it on Windows XP and Windows 10, etc., etc. You'd have to compile it down, and that EXE would only work on whatever operating system it needed. Also over here on the right, you'll notice that here's the intermediate language. So if you're ever curious what intermediate language actually looks like and why I said it looked kind of like assembler, you could go through here and actually take a look at it. So I think this is kind of a fun tool, and hopefully you can then, it just expands your mind about what could happen, security-wise to your application. So the next one I want to talk about is an application called Snoop. Now both of these I've given you in your example programs. Now what I'm going to do is I'm going to run this tic-tac-toe game that should look familiar. It was just a WPF, kind of just a little crazy game I created just to kind of show you animations and things like that. Well, what Snoop allows you to do is if I refresh this up here, it's going to give me all the EXEs that are running that are .NET that I could, decompile. So if I click this, and watch what happens if I click this little magnifying glass, this pops up over here. Now this is a reflection of this running, but I can now decompile the WPF. So watch what happens. I can actually go to 3D, make it a little bit larger so we can see it better. Now watch, I can grab this and drag it, and I can actually start seeing the depth of my application. See how it creates this 3D model for me? And down here, I can tell it show me the depth or the z-axis of my controls. Kind of cool, huh? Well, okay, this is really cool, Sean, but why the heck are you showing me this? Well, I want to show you at runtime, right? This is a running executable, how I can break apart your code, and I can look at hidden controls, I can look at how it's layered, and I can then kind of get an idea maybe how to hack it or how to use it, or again, this can also be used for your own purposes. I've solved real-world bugs using this exact application. Well, I was creating this mapping application, and I was dynamically creating these UI elements. So let's pretend I was dynamically creating this label up here. But what I mean by dynamically is as the code was running behind the scenes, I was recreating this UI element over and over again based on how it needed to look. So I'd create a new one, make it the right color and shape, and then display it. Well, I couldn't figure out where I got this memory leak from. Now remember, my application looked like this, and it was flat. And so when I would generate a new one, it just layered it over the old one, and I had like 50 of these, but I couldn't see them because I didn't, until I ran this and I did this, and all of a sudden 50 of them just broke apart, and I realized, oh my gosh, I needed one more line of code where I deleted the previous one before I added the new one on. But again, I never would have been able to see that bug, had I not used an application like this. So just again, I wanted to show you another tool that you can use to solve real problems. The next tool, or actually programming language I want to show you, is something called LabVIEW. LabVIEW is another programming language created by a company called National Instruments. Now the reason I want to show you this is because in this course I've gone over this lots of times where I've said I don't just want to make you or just a developer, I want to make you a software engineer, someone who can solve problems. Well, you always want to choose the right tool for the job. Far too many people I know end up with a favorite programming language, and they always try to use that programming language even if it's not the best fit for the job at hand. And that's what you want to do. You get a job and you then fit the programming language to the job, not the reverse. So if C++ is the way to go, then use that, not C#, or it may be C#, or it may be LabVIEW. based on what that application is needed for. For example, LabVIEW is great if you're interacting with hardware. So if you need to get temperatures and voltages and graphs and charts, LabVIEW is amazing. If you need to do things in parallel, very high scientific, high math intensive algorithms, LabVIEW is perfect for it. And now let's take a look at why that is. And again, I just want to show you LabVIEW so you could say, oh my gosh, this is completely different than anything I've ever seen before. Oh, there are more to computer science than just these text-based languages. There's so much more. So LabVIEW, this over here on the left is what's called our front panel. And this is sort of like the window in WPF. This panel on the right, this is our block diagram. This is where we write our code. Essentially, our C# goes over here. Except we don't write any code in LabVIEW. It's more like an electrical engineering diagram. So let's create a very, very simple application. I'm going to right click, and this brings up basically my toolbox, and you can see I have numeric controls, I have Boolean controls, I have string controls and graphs and layouts. So you can see they're kind of familiar. So if I go over here and I create a numeric control, this is like a text box, and I'm just going to call this, number 1. And this is just a text box that a person can only enter a number into. And I'm going to call this number 2. Now as I'm doing this, you probably notice over here on the right, it put these same 2 controls for code that I'm going to write. And I'll show you how that works in just a second. Let's say we want to take these 2 numbers and add them together. So rather than a control, I'm going to put an indicator here for my answer. So whatever number goes here, I'm going to add them together and show my answer here. So how do we write the code in LabVIEW that does this? Well, in LabVIEW, it's what's called data driven. So the data flows out of what are called wires, and then we write code to interact with that data. So here I can create for loops, I can create while loops, I can create arrays. I have numeric controls, like for instance adding and subtracting and multiplying. I have Boolean controls where I can and, I can or things together. So let's do something simple. Let's go here and let's select add. Now in LabVIEW, I know that the data is going to flow out of here, so I drag a wire to here. So the data flows out of there and into there. The data flows out of here and into there, and the answer flows out of here. So when I run this application, let's enter a couple numbers here. So 3 plus 1. Now when I run this, it runs 1 time, and then it gives me my answer. So the data flowed out of here, the number 3, 1 flowed out of here, it added it together, and it put it into my answer. Now there's a learning curve. These are called virtual instruments, and it's a little bit different. You can just run it 1 time. It's different than an exe. It actually figures out how to write the C code behind the scenes and actually does this all for us. But we write it like this. Now there's advantages to writing code this way. For example, if I were to create something like this, I'll just put these controls over here, it doesn't really matter. What LabVIEW does for you automatically, because it's data driven, notice how the data flows out of these wires. What I'm going to do is I'm going to turn on this little highlight execution on here and then run the code and see how the data flows out of those wires. And you can kind of see visually, you can debug it and see the data flow. So you saw the number 3. So watch right here and watch the number 3 flow out of that wire. See how the 3 flowed out of that wire and 1 flowed out of that one? And so that's what's going on behind the scenes. Now notice, in order to do any of the execution, again, pretend this is a really complicated algorithm. But notice how nothing in this algorithm has anything to do with the data over here. Well, that tells the compiler this and this can be executed in parallel. So again, imagine this was a highly intensive math algorithm that we're trying to do some scientific plotting. And we had to execute this over and over again. Well, this would automatically take care of the multi-threading for us. And so we as humans can just code it as it's logical to us, and it will take care of the complexities of parallelizing our code. Now you'll also notice that when I run this, it just runs 1 time. So I could come in here and do like a while loop, for instance, that tells me, hey, I just want to run this forever. And see this little stop button over here? I can create a control here. See this stop button? So what this says is, it says run over and over and over again until someone clicks this stop button. And also I'm going to add in this little wait control here, because in LabVIEW you have to add in your own wait. So where C# is what it's called event driven, so it takes care of that for you. In LabVIEW, this will just run as fast as possible, and we actually want it to give it a little bit delay so we can interact it with the UI. Now watch what happens now. So now when I run it, it's actually running in real time, it's doing that math. A little bit easier to see if I turn on this highlight execution again. But you can see this pumps a false out, so this says false. So it says continue executing. Now it doesn't necessarily, it kind of goes from left to right. See how then it comes back around. You can think of the code executing here, and it pulls through, and then it goes through the answers. You can see as I change these numbers here, it's going to change the number that flows out of that wire. Again, nothing to do with this class, but I just wanted to kind of open your mind a little bit. This is another paradigm, another way that you could program for the real world. So hopefully some of these just kind of interest you, and you can look up these new technologies and kind of play with them on your own. Thank you.